All right, so we want to examine this idea of adding and subtracting rational expressions, and I want to relate it to um, really adding and subtracting fractions, because rational expressions are just fractions with expressions in the denominator. So I have 2/9 minus 1/6, and when you were in elementary school, you would find something called a least common denominator. And the least common denominator is really just the number that both of these fit into, but is the least amount of value. So you're probably like, Ms. Crisco, I know exactly what this is. This is 18, right? But when you were in elementary school, this concept was pretty challenging. And the reason why it's 18 kind of stems from this idea of factors and common factors. We could rewrite 2/9 as 2 over 3 times 3, right? And we could rewrite 1/6 as 1 over 2 times 3. Notice how both of these fractions have a common factor of 3. And the part that's different is really just this 3 and the 2. So you would wind up multiplying this fraction by a 3 over 3 and this fraction by a 2 over 2. And that should make sense. Look at the problem above. To make a 6 into an 18, we multiply it by 3 over 3, and a 9 into an 18, it's a 2 over 2. So I'm going to ask you to keep this concept in the back of your mind as we explore our rational expression example. So let's see if we can derive one. How about, let's do this example. 2 over 3x squared minus 12. And how about minus 5 over 6x, let's do minus 12. So similar, not completely the same. So the idea is that you want to break down your denominators into or factored parts. So 3x squared minus 12 could be factored into a 3 parentheses x squared minus 4. And then I could go another round on that, couldn't I? Let's actually rewrite this whole fraction. 2 over 3 parentheses x plus 2 and an x minus 2. Is that okay? So far, so good? All right, now over here I have a minus 5 over, let's see, really just a GCF here. Looks like a 6 times an x minus 2. All right, not too bad. So now I'm in this goal of finding a least common denominator. And the way we do that is really to look at the factored parts. They both have an x minus 2 in common, so I'm going to include that in my least common denominator. This guy's missing the x plus 2, so he's going to have to be in there. And then on this one, let's see, 3 and 6. In order to transform this 3 into a 6, I would have to multiply this by 2 over 2. So let's look at our least common denominator. Our least common denominator would be a 6, because 3 will enter 6 evenly, an x plus 2, and an x minus 2. And really what you want to do is just transform each one of these expressions into your least common denominator. So I'm going to kind of just go right ahead and put my least common denominator in the bottom of both of these expressions. Okay, so now I'm trying to transform this into this. What would I have to do? Oh, I just have to multiply by 2 over 2, right? So that gives me 4 in the numerator over my common denominator, 6, x plus 2, x minus 2. And then over here, I'm trying to transform this 6x minus 2 into a 6x plus 2, x minus 2. So Here, I would have to multiply by an x plus 2 on top and bottom. All right, so that would give me, let's see, a 5x plus 10. Now, this is the one important part. As you go to simplify your numerators, notice how you're subtracting this expression. You need to make sure that you're subtracting both parts as you combine like terms. So I have a 4, a minus 5x, and a minus 10. This is really a common error that I've noticed many times. All right, before I write down my actual common denominator, I'm going to combine my like terms. Let's see, 4 minus 10 gives me a minus 6. And then all over that common denominator. And you don't have to multiply it out. You really can just leave it in factored form. It's just important that you simplify your numerator. So I hope that helped. Your goal is to factor, find the common part, transform each rational expression, and then combine your like terms. All right, good luck on your homework, ladies. I will see you soon.